Today we are going to discuss the Ophiolite suits. The term ophiolite is used to a distinctive rock assemblage containing ultramafic, gabbroic, basaltic rocks often capped by layers of deep sea sediments. The distinctive association of rock resembles oceanic crust and upper mantle in both thickness and sequence. Ophiolites are fragments of oceanic plates that have been somehow thrust into subaerial environment. The well described, you can say the characteristic or ideal ophiolite suits are located at Bay of Bengal, Bay of Islands in Newfoundland and eastern Papua and New Guinea. The emplacement of ophiolites may occur as a result of collision between continental and oceanic plates or between two oceanic plates. The one of the, you can say, the characteristic, that is the usual underthrusting mechanism causes the denser oceanic plate to slide beneath the lighter continental plate. However, in the initial stages of collision, the reverse might occur with the oceanic plate overriding the continental plate. This process results in seaward dipping subduction zone and is called abduction. As abduction occurs, the oceanic plate is thrust over continental plate. Abduction is basically an unstable mechanism and the process is followed by reversal with the oceanic plate descending under the continental plate. In the absence of abduction, the normal subduction process, that is oceanic plate under thrusting a continental plate, results in considerable fracturing of the oceanic plate. Blocks of oceanic material may be torn from the descending plate to ride tectonically into the melange above. Tectonic movement of this type is indicated in the Franciscan Formation of California, where ophiolites are serpentized peridotites are closely associated with highly deformed areas. Now, the typical, in the diagram, you can see an section. This is the diagram. In this, yes, I can remove it and I can start again. Yes, this is the sequence of the ophiolite suit. You can see from A, B, C, D, E. This is A, B, C, D, E, F. Now this sequence, if you take it, A, this is the bottommost. This is your metamorphic areole. These are moderately metamorphosed rocks containing pyroxene, garnet, amphibole, plagioclase that show considerable deformation. This is thought to represent the layer within which the abduction of hot oceanic crust and mantle occurred. So this is the bottommost, you can say, the layer of an ophiolite suit, and it is of your primary mantle, you can say, or metamorphic areole. The next B, it is your metamorphic rocks found. Above these metamorphic rocks are found your ultra basic rocks. This is your ultra basic rocks, thought to consist both primary and depleted mantle, the refracted residue, partial melting process. The rocks consist of Herzbergite. Herzbergite is 75% olivine and 25% Herzbergite. You see it here. In the B, this is Hardenbergite. This rock type is your, I told you, it is 75% olivine and 25% orthorhombic pyroxene, that is OPX, and dunite, mostly olivine. With lazurolite at the base. This lazurolite is composed of a mixture of your olivine, clinopyroxene and orthopyroxene, both, that is CPX and OPX. A distinctive mineralogical banding is present in these rocks. Considerable deformation and serpentinization is evident. A mental origin is indicated by spinel and high aluminium content in the clinopyroxenes. So the means the mental origin is indicated because by spinel and high aluminium content in this is that, right. Then above this B, this is your C. Above these ultra basic rocks is the transition zone characterized by first separate plagioclase, that is your plagioclase, and distinctive cumulative, this is your C, sorry, this is your C, this is we are talking of this one, right. So this is your, you can say, above ultra basic rocks, the transition zone characterized by first appearance of plagioclase and distinct cumulative texture. Crystal settling resulted in cumulative layers rich in anorthite, dunite, troctolite or clinopyroxene. The general rock type is composed of calcic plagioclase, clinopyroxene and olivine with minor chromite, magnetite, sulfides. Troctolite is chiefly composed of calcic plagioclase, usually labradorite, and olivine with little or no pyroxene. Means this you can say in general that is the gabbroic in that sense. Troctolite is composed chiefly of plagioclase, labradorite, olivine with little or no pyroxene. Overlying the cumulative transition zone are fairly structures of gabbros containing plagioclase, means AN more than, you can say, that is 70%, right, clinopyroxenes and your olivine. The Mg upon Mg-Fe ratio decreases upward. This is interesting. The Mg upon Mg plus Fe ratio decreases upward within the gabbro, indicating some fractionation. So in this gabbro, we are talking of this gabbro. In this you find, if you, the chemical analysis has given, or the Mg upon Mg plus Fe ratio decreases upward, means you go, this is decreases upward. It means that in the gabbro some fractionation has occurred, indicating fractionation, right. Then above the C is your D. This is your D, that is your intrusions of your sheeted dikes and dike breccias. Sheeted dikes are found above the gabbro, some of which are strongly brecciated. Dikes are found within the gabbro below, indicating this. Dikes are younger than the gabbro, as in contact with approach the number of dikes increases upward until the point reached where the total mass consists of dikes. Minerals present in these intrusions, minerals that are present are plagioclase, clinopyroxenes, magnetite, and the texture is fine grained, diabasic, porphyritic. The next layer above this D is your E, that is your extrusions, that is of pillow basalts. It's interesting, pillow basalts which are somewhat altered. A few dikes are present within the basalt, means this extrusion pillow lavas, because they are formed underwater and this basalt is there. And the final, the topmost layer, that is your, this is your sediments, that is your the sediments that are abyssal sediments. They may be your wall found in this your sequence conglomerate, sandstone and siltstones. So this typical sequence of rock types, and is considered, this is in typical, you can say, the sequence. Inside you can see the depth also from in kilometers, this side depth, right. And this is the sequence of a typical ophiolite suite, means from A to your F, these are the different rock types from metamorphic to your ultra basic to your basic, then your dikes, and ultimately your, you say, the pillow lavas and the sediments. So this is what is your the ophiolite sequence, and these ophiolites is a distinctive, you can say, rock assemblage containing these ultramafic, gabbroic, and basaltic rock types, often capped by layers of deep sea sediments. So this typical sequence of in different parts of the, you can say, earth is has been considered, and it is due to the under thrusting mechanism, means they are the, you can say, when there is oceanic plate, they are the, you can say, the remnant or they are indicator of the plate collisions. When this oceanic plates initially rides over the continental plates, it dips toward the ocean side. This is called abduction, and later on it slides beneath the your continental plate, and then there is an, you can say, this under thrusting making causes denser plate to slide beneath the lighter plate. How in the initial stages of collision reverse might occur, right? That is something different, but ultimately it is a subduction, and that is called, in the initial convergence of continental and oceanic plates, abduction may occur. The process thrust oceanic crust and mantle into the continental edge. The distinct association of your ultramafic, gabbroic, diabasic rocks often capped by sediments. So this is an indicator, because now that the, you can say, it is in blocks of your oceanic plates that are, you can, the fragments that are there, it is indicating of this plate collisions, that is sequence. Now once again, just I want to say this typical, and a student of igneous petrology, you should get acquainted with these names which are written here. So I want to clear it, because once we say Hazarbergite, when they say the Hazarbergite rock type, means Hazarbergite is nothing but it is simply a rock having 75% olivine and 25% orthopyroxene. So this term should be clear as a student right now, that Hazarbergite, it is means a rock, it is ultramafic rock which has 75% olivine and 25% OPX, means orthorhombic pyroxene. Similarly, if you come slightly this is a rock type, this is called your lazurite, which is lazurite. This is, now this is composed of olivine and your clinopyroxenes and orthorhombic pyroxenes. Now here it is three both, that is your olivine, clinopyroxene as well as orthorhombic pyroxenes. So means basically again it is both these are ultramafic rocks in that sense, means cause olivine, pyroxenes. Now pyroxene, both pyroxenes, OPX and CPX, right? Similarly, if you come here, it is clinopyroxenite, means only clinopyroxenes. Clinopyroxenes, you understand, means orthorhombic pyroxenes and clinopyroxene, monoclinic pyroxenes, you can say it. That is your diapside, augite, right? The pyroxenes. Then copper. Then it is anorthosite. Anorthosite is monomineral rock having your, that is labradorite, that is calcic feldspar, dominant composition. And just we said in the that is your composition, that is your troctolites is composed chiefly of the labradorite and olivine. This is troctolite. This is troctolite name here it is. So troctolite is your olivine plus your labradorite. Again it is in plagioclase feldspar. Labradorite, that is your calcic feldspar. And this is the plagioclase, calcic feldspar, and olivine with little or no pyroxenes. So this is labradorite. Gabbro, you all have the gabbro composition. It is your labradorite plus your clinopyroxenes. So these are the different, you can say, the association or the sequence of different metamorphic, ultramafic, basic, and finally ultimately they are kept by sediments. This is the Ophiolite Suite, right? And I gave you in the initial stages, it is due to that when there is a collision of continental oceanic plates, initially there is an the oceanic plate dips toward the ocean, and that is called abduction. Ultimately the reversal takes place, it dips beneath the continental plate, that is subduction. Ultimately when it breaks up, and this the fragment part, that is this such sequence of rocks is preserved, and that is your ophiolite suits. So this is all about the ophiolite suits, and the different examples just I gave you in the beginning. You can see the worldwide, the different in your, say, the first in the this is in the Bay of Islands, Newfoundland. This is the diagram of basically of that particular place, that is the Bay of Island, Ophiolite, Newfoundland. Ocean creates the so this is the various other, you can say, the parts where these ophiolite suits are studied and are, you can say, this is in the Franciscan formation in California, where ophiolites are serpentized, I told you in the beginning, and and number of places other also the such sequences are being found. So to an student of petrology, I have igneous petrology or say petrology, means this is whenever is a sequence is inferred or it is being studied, means that is indication of plate movements, plate collisions, where oceanic plate has subducted into the continental plate and that part has been fragmented, and such sequence of rocks are found, that is known as by the ophiolite suits. Thank you very much. That's all for today. Thank you.